Hi everyone, let's see one of the question on functional dependency. Here they are asking for find the following preserved or not for the given decomposition. Means they are asking that whether attribute preservative or lossless join decomposition is preservative or functional dependency preservative or not for the given decomposition D. Means simply they have given a relation R with set of attributes A, B, C, D, E, and a set of functional dependencies they have given, and set of decomposed relations are also given. You need to define finally all these three are possible or not. Right? So guys, you know the meaning of attribute preservative means you have to take out the relation R1 attributes and relation R2 attributes and so on, relation Rm attributes. Finally you have to make them union. If those attributes are equal to actual relation attributes, I can say that attribute preservative. So first try to check for A, right? In A, for the A question, you have to take out the attributes A comma B comma C, first relation union, second relation A comma B comma D comma E, third relation E comma G, right? Guys, what you are going to get? Are you going to get all the attributes A, B, C, D, E, G, right? A, B, C, D, E and G, right? So is it equal to actual relation attributes A, B, C, D, E, G? Yes. So I can say that attribute is preserving. Attribute is preserving, right? Similarly, try to do it with the second one. Is it lossless decomposition? For that, what you can do, you can go with two ways. One is intersection method. Another one is tabular method. Guys, you know that, right? So you can just go with the previous videos, you can get clarity about this one, right? So for the sake of simplicity, I am going with the intersection method, guys, right? So in intersection method, we are going to find out the common attribute for the relations. See, first I will try to take out first relation ABC, second relation ABDE. What is the common attribute between these two? B is the common attribute, right? So before going to combine these two relations, first I need to find out whether it is a candidate key or not. So I will find out the B closure. What is B closure here? You are going to get B closure is from B I can get B as well as D, and any other things are possible from BD. Is there anything are possible? No, nothing is possible, right? So I can say that here B is not a candidate key. B is not a candidate, so I cannot able to combine these two as of now. So try to take out the another relation easy. Now try to combine these two, right? If I am trying to combine these two, you have to check this common attribute is candidate key or not. So find out E closure. E closure if you find, you will get E G. Means that E is a candidate here as it is deriving one complete relation. So now finally I can combine these two as a single relation, right? So you will get A, B, D, E, G. A, B, D, E, G. Now once you got A, B, D, E, G, now take out the other relation A, B, C. Now try to combine, right? If you are going to combine, you have observed here there is a common attributes are AB. Attributes are AB, right? So earlier also the common attributes are AB, guys. Common attributes are AB. If you take AB, maybe it is possible, right? Okay. So try to find out the check whether it is a candidate key or not. So what is AB closure? Definitely you are going to get AB, and from AB you will get C. Means that it is going to derive one of the relation. So I can call it as it is a candidate key. So finally I can combine them as a single relation. So you will get A, B, C, D, E, G. Finally you are going to get entire relation. I can say that it is lossless decomposition. Lossless decomposition, guys, right? So here here also you can combine actually, but at the time I have taken only B as a key, B as a common attribute, but actually it is AB. If it is AB, you can go with this one, right? So you can do it in many ways. Like you can combine, like if you have three chances, three relations R1, R2 and R3, you can combine first R1 and R2, and then you can combine this with this one, or you can combine R2 and R3, then you can combine this entire thing. Or if you have R1, R2, R3, first you can combine R1 and R3, then you can combine R1, R3 with R2. So like this you are going to have many possibilities. You can do it in any other, but at the end you have to have the actual relation. Then you can call it as lossless decomposition, or I can say that lossless join property is preserving, right? So you can go with the tabular method by yourself, right? Next one is FD preserving or not. Guys, for FD preserving or not, you have to find out the set of FDs possible for the relation R1, I can call it as F2. The set of FDs possible for the relation R2, I can call it as F2, and so on. The set of FDs possible for the relation RM, I can call it as FM. Finally, you need to combine all those, and if any functional dependencies are not preserving, you have to find out its closure, and if it is equivalent to the actual relation closure, I can say that FD preserving. So for that, what you can do, guys, you can just take the first relation ABC, try to find out its functional dependencies. So we can define the functional dependencies as with single level attributes. So that is A closure. If you are going to find out A closure, you are not going to get anything. So I can simply say that trivial. So I cannot able to consider. B closure, you are going to get B. From B you can get D. You can get D, but D is not in our relation, so I can simply skip this one, right? Similarly, you can find out the C closure. C closure is C only. Okay, fine. Similarly, you have to go with the two level functional dependencies. AB closure. AB closure is AB, C, good. From AC you will get anyway B is there. From anything are possible. From BC you will get A, anyway it is there. And anything are possible. From B you can get D, guys. But the thing is, D is a kind of a attribute which is not present in this relation, so I can just simply skip this one. AB is a trivial, so I can get the functional dependency as AB determines C. See, if you want to have more clarity step by step, you can go with the previous videos. Next possibility is AC closure. AC closure is AC, and from AC you will get B, right? From BC you will get A, from B you can get a D. D is anyway is not in the relation, so finally you are going to get AC determines B is one kind of functional dependency possible. Similarly, you have to find out BC closure. BC closure is BC. From BC you can get A. You can get A. So you are going to get BC determines A is one more kind of FD possible, right? Next, if you take ABC closure, you are going to get anyway trivial along with some of the attributes which may not be present in our relation. So I can say that it is not possible. So these are the set of FDs possible on the relation R1. I can say that ABC. Similarly, try to find out the set of FDs possible on the relation ABDE, right? So now try to check the FDs for A. If you find out A, you are going to get only A. So I can simply skip this one. If you are trying to find out the B closure, you are going to get B. From B you can get D, good. From D you can get anything? No. So from this I can say that B determines D is one of the FD possible on this relation. Similarly, try to check out D closure. D closure is I think nothing except trivial. So similarly, E closure is E. Anyway you are going to get G, but this G is not in the our relation. So I can say that I can simply skip this one. A, B, D, E, all single level attributes are done. Now go with the two level attributes. AB closure. If you are able to find out AB closure, you are going to get A, B. From B you can get D. From AD you can get G, guys. From AD you can get G. Okay. Anyway, it is not present in our relation, so you can skip this one. And any other things are possible? No. So AB determines D is one of the FD possible, right? Next, try to check out for AD closure. If you find out AD closure, you are going to get AD. From AD you can get G. Which is not in the relation. I think it is, that's it, right? So this is trivial only. Similarly, AE closure is, you are going to get AE, from E you can get G, so which is again not in the relation, and other one is a kind of trivial, so I can simply skip this one. Similarly, next go with BD closure, next possibility of two level relation. BD closure is BD, from BD you can get anything, nothing, so BD is a trivial. Similarly, BE closure, BE, from E you can get G, from B you can get D, guys, from B you can get D, right? So means that BE determines D is possible, as they are in the same relation, and G is anyway is not in the relation, so I can simply skip that, right? Similarly, you have to go with DE closure. Guys, I am trying to check for all, right? AB, AD, AE. Similarly, BD, BE, and I am trying to do it for DE now, right? If you find out the DE closure, you are going to get DE, from E I can get G. Any other things are possible? No. So here G is out of relation and DE is a trivial, so I can able to simply skip this one. Once we done two level, you have to go with three level, guys. Three levels are ABD, ABE, BDE closures, right? ABD, ABE, BDE. Any other things are possible? Right? So you can go with ADE also. ADE, ABD, ABE, ADE, ABD, anyway you are going to get, right? So these are the four things possibility here. So try to check out its closures. If you check out its closure, ABD closure, you are going to get obviously trivial first. From A, B you can get C, which is not in the relation. From AD you can get G, which is not in the relation. If you are going to have AC, you will get B, AD you are going to get G, B you are going to get D, it is there, BC you are going to get A, it is there, E determines G, right? E is not there, right? So from ABD you are going to get only the trivial, so which is not going to be an FD. Similarly, ABE closure, you are going to get ABE, from AB you are going to get C, which is not in the relation. From AC anyway you are going to get B, which is already there. Is there any chance to get AD? No. Is there a chance to get B? B determines D now. B determines D now, right? If you got the D from A, so I can combine it as AD. AD determines G again. G is not in the FD. So you are going to get D is possibility is there. Any other things are there? E determines G anyway. BC determines A. So I think all are done. All are done. So if you are able to observe here, ABA anyway is trivial. D is the new one. So ABE determines D is the one of the new FD for this relation, right? Similarly, try to find out BDE closure. You are going to get BDE anyway. From B, are you going to get anything? BD, you are going to get anything? No. E, you are going to get G, which is non-availability of the relation. So I can get only trivial. So I can able to simply skip this one. Similarly, ADE closure. So you are going to get ADE anyway. So from D, no. From A, no. From E, you will get G, which is again a non-existing relation attribute. So ADE closure is not going to define any new FDs for this relation, right? All three level done. Now try to go with 4 level, right? If you go with 4 level, obviously it is going to determine the set of the things A, B, D, right? Which is a trivial. It may determine any other new FDs also. They are not in our relation. So I can say that which we should not consider, right? So these are the FDs, right? So the FDs possible in the relation R to R. B determines D and AB determines D. B determines D. AB determines D, right? Fine. Next, try to find out the FDs possible in the relation EG, right? So if you find out, you are going to get E closure first. E closure is EG, which I can say that E determines G is possible. Next, if you find out the G closure, which is G only, so I cannot yet consider, and 2 level attributes I should not consider because it is equivalent to the actual relation. So these are the FDs possible in the relation R3. I can say that E determines G. Now finally you have to check whether the decomposed relation FDs is preserving the actual FDs or not. So for that, what you can do, first try to take out AB determines C. Is it preserving somewhere? Yes, if you are able to observe, it is preserving. Is AC determines B? AC determines B? Yes, it is preserving somewhere. So I can say able to say that it is satisfied. Is AD determines G? Is satisfying? Is AD determines G is satisfying? Guys, wait. So here if you are able to observe, AD determines G is not there. Is not there. So now what you can do now? You have to find out the closure for this one. You have to find out the closure for this one, right? If you are able to find out the closure for AD on the sub decomposed relations, sub relations, right? So what is AD closure on sub relations? From AD you can get AD first. AD, good. And then inner things are possible. So means you have to try to do with A. Is there any things are there? No. Is there any other things are there with the D? No. So is there any other things are possible with respect to AD? No. So AD closure is you are going to get only AD. AD closure is only AD, which means that this is not preserving in the decomposed relations. So I can say that if at least one is not satisfying, this decomposition is not FD preserving, right? So you can check with other also, but even if all others satisfied, so as at least one is not satisfied, I can say that FD is not preserving. I hope you understood clearly. Thank you.